Guys, that's okay. Dat was niet mooi. Maar dat was voor de staten van de feest, dat was een tweedaagse congres. Dat is nieuw. Ja, dat is het werkelijk. Nee, dat was tof voor de veel koude mensen. Ik ga eens er is een liedje. Ja, nee, maar iemand met tickets, die heeft eigenlijk melodie gestuurd. Oké, dat zou te doen op zich. Ja. Probeer dat. Dat is voornamelijk iets populair. En een keyboard is het voorbeeld.
Sorry, that's for urgency purchase. Oh, she has one. It's the same as mine. Yes. Are you joking? She knew it, huh?
Direct Taylor Swift. Maar ik denk dat het restaurant is om als je iemand hebt of zo. En er zijn zo van die melodieën op een gegeven moment.
It's what the teacher. De midden de
waarom doen we dat niet?
I've seen midden met ogen. What we see. Yeah, exactly. Middle of us.
Yes. Yes.
On commence, moi je commence en français.
Tu peux commencer en anglais.
Ok. Déjà? Okay.
Oui.
Okay. Hello. Thank you for being here. My name is Camilla. I'm the co-founder and co-director of OM. And before we begin, I will afterwards explain who is Om and Woyu. But before we begin, we want to read a little statement that we prepared in the framework of what is happening in this country in this moment. We want to share our support for the national intersectional strike that is taking place today. It's the third and final day of an unprecedented mobilization movement. The cultural sector mobilized this afternoon with picket line in front of cultural institution and Grand Tribune at the Mont des Arts this afternoon. As Om, we are one of the co-founders of ASAP, and since we are here at ISELP, which is also a co-founder of ASAP, we feel that it is essential to highlight the particularly concerning situation facing the visual art sector. ASAP is the Assembly of Visual Arts Structures, is the first federation of sector operators in the French-speaking part of Belgium. La FAP is the Visual Art Federation and represents the visual art workers. The two organizations are working together to defend the sector. Visual arts is the only non-indexed cultural sector in Fédération Wallonie-Bruxelles. The recently announced freeze on requests for funding increases and recognition amounts to a progressive defunding of our institution, directly threatening the sustainability of our structure, employments for workers, and remuneration for artists is a catastrophe. In the face of austerity measure affecting the entire cultural sector, we call on the governments to defend and refinance the culture in all its diversity, to cancel the budget cuts and the cultural sector, strengthen the artist allocation system, implement collective agreements to improve working conditions, and refinance the public services and lifelong learning programs. The fight for the cultural sector rights, we believe, is inseparable from the fight for everyone's right.
Okay, so now in French, to be understood by everyone. Okay. Donc avant de commencer, on tenait vraiment à affirmer notre soutien à la grève intersectorielle nationale qui se déroule aujourd'hui. Troisième et dernier jour d'un mouvement de mobilisation conséquent ici en Belgique. Le secteur culturel s'est mobilisé ce matin avec des piquets devant les institutions culturelles et une grande tribune au Mont des Arts cet après-midi, en tant que O, l'une des structures cofondatrices d'ASAP, et puisqu'on est ici à l'ISEL, qui est également cofondateur d'ASAP, ça nous semble essentiel de souligner la situation particulièrement préoccupante dans laquelle se trouve le secteur des arts plastiques aujourd'hui. ASAP, qui est l'Assemblée des structures en arts plastiques, est la première fédération des opérateurs du secteur en Belgique francophone, et la FAP, la Fédération des arts plastiques, représente quant à elle les travailleurs et les travailleuses des arts plastiques. Les deux organisations travaillent ensemble pour défendre notre secteur. Les arts plastiques sont le seul secteur de la culture non indexé en Fédération Wallonie-Bruxelles. Le GEL récemment annoncé des demandes d'augmentation et de reconnaissance équivaut à un définancement progressif de nos institutions, menaçant directement la pérennité de nos structures, de nos organisations, l'emploi des travailleuses et des travailleurs dans notre secteur et la rémunération des artistes. Donc, face aux mesures d'austérité qui touchent l'ensemble du secteur culturel, on appelle vraiment les gouvernements à, petite liste, défendre et refinancer la culture dans toute sa diversité, annuler les coupes budgétaires du secteur culturel, renforcer l'allocation des travailleurs et travailleuses des arts, mettre en place des conventions collectives pour améliorer les conditions de travail. Il manque une page. Et enfin, refinancer nos services publics et l'éducation permanente. Donc, la lutte pour les droits du secteur culturel est, selon nous, indissociable de la lutte pour les droits de toutes et tous. Voilà, merci beaucoup. C'était la petite introduction.
Bonsoir à toutes et à tous. Merci Raoul et Camilla d'avoir fait cette introduction. C'était super important. Merci. Good evening, everyone. My name is Mélanie Réville, and I'm responsible for research here at ISELP. ISELP is a contemporary art center, and we support, disseminate, produce, and accompany research in both art and art history. We produce podcasts, host talks, symposia, guided tours, exhibitions, and many other events that bring people together around artistic creation. Tonight we're here in the context of Uncharted, an exhibition organized by OM and produced in collaboration with ISEP. And if you haven't had the chance to see it yet, there's still a week left. It runs until Saturday, December 6th, and I warmly encourage you to visit. It's just here upstairs. OM has prepared a wonderful program of talks, discussions, and performances to accompany this exhibition, and we're about to experience the last event in that series. So without any further delay, I I'll hand the floor over to them. Good evening. Thank you for being here.
Hello, very happy to see you, everybody here. Hello, our spectators on the stream. So I'm represent Brussels LisaTalk. My name is Alexandra Dementьева, and today we will have a very interesting discussion beyond the map on listening, measuring, and imagining the unexplored, and collaboration like already we heard with OM and hosted by Ezel. And a few words about LisaTalk. This is a program of international gathering that bring artists, scientists, humanists, and technologists together for informal presentation, performances, and conversation with the wider public. The mission of LASER is to encourage a contribution to cultural environment of a region by fostering interdisciplinary dialogue and opportunity for community building over the 50 cities and continent worldwide. So I would like to give the floor to Raul Sommelier, who will moderate this talk, and to invite on the stage SVM and Frank Bacane.
Thank you very much, Melanie. Thank you very much, Alexandra. So, yeah, you can come. Let's go. So, to frame this event and give you a bit of context. So, yeah, I'm Raoul, one of the co-directors of OM, more in charge of the research, education, and lab activities, as well as Nicolas, which is there behind the camera, and Camila, that you already know. So OM is a Brussels-based organization that is really trying to collaborate researchers and artists together to create a large panel of results, activity, explorations. It comes really from exhibition. It's the case of Uncharted here, to educational program, and we have also artist residencies that we may collaborate with research labs, some education program in art schools, etc., etc. If you want more information, we have a beautiful website done by Ophelia, which is there too. So tonight's conversation is part of the satellite program of Uncharted. This exhibition questions our relationship with the materiality of Earth, the visible but also the invisible, the boundaries that compose it, and the narratives that we as humans construct to understand its transformations. It looks at the limits of our perception, at the hidden process shaping landscapes like ice sheets that we talk about later, and the ways artists and scientists attempt to make sense of what lies beyond the map, so beyond what can be immediately measurable or visible. So this evening, the idea is really to bring together two practices that approach the unknown from different angles, quite complementary in our opinion. One through field recording, listening, and proposing sensory experiences, and the other through measurements, field work, and modeling. Yet both approaches deal with phenomena that resist easy representation, slow movement, hidden forces, vast environments and landscapes that we cannot really grasp all at once. So the idea is really not here to oppose artistic and scientific perspective or approaches, but to see how their methods, their intuitions, and their imaginaries can cross-pollinizing each other, and how these different perspectives might help us rethink how we engage with the unexplored. So we have two really nice speakers with us today. I just want to thank you for being there. We'll start with Frank. So the idea, maybe to give you a bit of timing, so the idea is to have 15 minutes presentations per speaker, and afterwards we will have moderated conversations together, the three of us, but maybe with you too. So the idea is that you can engage with us too. So we'll start with Frank. So Frank is a professor, glaciologist, and ice sheet modeler at the ULB, so Université Libre de Bruxelles. He's a leading expert on the dynamics of glaciers and large ice sheets, known internationally for developing ice flow models that improve projections of future sea level rise. He has participated in more than a dozen Antarctic expeditions. He chairs the Belgian National Committee on Antarctic Research and received different medals for his contribution to glaciology, as well as the ULB Scientific Dissemination Prize for his public engagement on climate issues. But Frank is also a musician. So through climate data sonification, he transforms environmental data sets into melodies, asking whether climate change can not only be measured or visualized, but actually heard, which is also the topic of tonight. Each composition is built directly from scientific data, temperatures, ice mass variations, sea level rise, etc. In doing so, he turns the planet's changing rhythms into sound, making scientific information perceptible in a completely different way. So tonight, he will share both his scientific insight into ice sheet dynamics, but also his musical approach to listening to climate change. So thank you, Frank, for being there, and the floor is yours.
Thank you. Okay. Well, thank you very much, Raoul, and good evening, everyone. So I'm Frank, and I will kick this off with a little story about ice, and both a mathematical and a auditory journey through the ice. So yeah, ice covers about 10% of the total Earth, so that is not negligible. It's like the same as deserts or the same as tropical forests, so it's not negligible. And there are different types of ice. First of all, most of the ice is found at the poles, at the North Pole and South Pole. The North Pole, you have an ocean that is covered by ice, and that is called sea ice. But you do have land ice there. So there is a little continent, or it's the biggest island on Earth. It's called Greenland, and it's covered with an ice mass. And then if you go to the South Pole, we have a big continent surrounded by oceans. It's just the inverse of the North Pole. That is covered by ice, and around it, it's surrounded by sea ice. And there's a big difference between sea ice and land ice. And it's a difference that I always have to make, especially to journalists, because there's a lot of confusion. So sea ice is the frozen surface of the ocean, and by that it's just a thin layer of just 50 centimeters to a meter or a couple of meters. And it plays an incredibly important role in the radiation budget of the Earth because it reflects the energy back to space. And it cools down the Earth. So if you have less sea ice, the Earth warms up more. And then we have the ice sheets. These are huge volumes of ice. If you take all these volumes and you would melt them, well, all that ice would flow into the oceans, and that would raise sea level by more than 50 meters. And so the sea ice doesn't influence the sea level. It's just a frozen layer on top of the ocean, but the land ice influences it. And so this is what I study. I study that land ice, not so much that sea ice, but that land ice has changed over the last couple of decades, over the last century. And even over the last 3,000 years, we see that we have never seen anything before in the rise of sea level. Now, I study particularly Antarctica and the Antarctic ice sheet. And you would think that even though it's part of Earth, we know a lot about it. And it's still part of, something that we haven't measured enough. This shows what we know about the ice thickness of the Antarctic ice sheet. And 25 years ago, when I was a young postdoc, then you see in this first picture, this is the amount of trajectories where people have either by airplane or by on the surface have measured the thickness of the ice sheet. So you have many blank spaces, unmapped, completely unmapped, uncharted, as we could say here. And so gradually, if we see it now in 2024, 25, well, there are still blank spaces. You have to know we have to do this by airplane, and we have to do this over land. We have to go there. We cannot do this with satellites because it would the frequencies that you need to use interfere with our communication. Right now, we know more about the ice sheets on the planet of Mars than we know on our own planet. Because there we don't care about communication. On Mars, we can use any frequency we would use. It interferes maybe with those little green Marsmen that we don't care about. So, but this gives you an idea on what is looking underneath the ice. And that is basically what we need to understand what such an ice sheet is doing, knowing what is underneath the ice sheet. And you see this is the whole bedrock. You see some valleys, you see deeply carved canyons that you see the dark blue areas. So it's quite amazing to see the topography underneath the Antarctic ice sheet. Now, I have been a couple of times to Antarctica and where we do measurements, but these are very small points in the middle of nowhere. I put a little map there of Antarctica compared to Europe, and the spot, the little circle, the spot where this was taken, it's a little on the coast of the Antarctic ice sheet. And this is our camp. We have in the bottom, I made a measurement where we did a drilling into the ice. But just to give you an idea of the scale, so this is our little tent camp. And so we spent there a month doing our work in the middle of a complete white, empty place. There's nothing but snow and ice. And so now we're looking towards the south. So basically, if I'm in the north of the Baltic Sea, I'm now looking towards Italy. But there's nothing to see. It's a vast area of ice and snow. The only way we get around is by using a GPS. It's mathematically. But of course, we can use satellites, and that is our primary way of measuring and understanding what the ice sheet is doing. Because from space, you get a complete overview of what the ice sheet is doing. So you can see how fast the ice is flowing. You can see what is the surface elevation of the ice sheet, and also how that is changing. And here we see how this has been changed over the last decades. This is done with gravimeter. This is data from NASA that I recovered recently, because you can go now to the NASA's websites. They're all completely shut down. There's no way to get the data now. Of course, in Europe, we recovered that. Most of them are in Germany now. But so this is a way you see that the Greenland ice sheet is reacting differently than the Antarctic, but you see these color, is it red colors? Because I'm colorblind. Orange, yeah. So they show where you have thinning of the ice, and in Antarctica it's focalized into one area. In Greenland, it's all around. And this is so they are losing mass as a reaction to climate change, but also for different reasons, because there are different mechanisms at play. The only thing that measurements cannot do is to predict what is going to happen in the future. And the only way to predict is to make use of models. And this is something that I have been done over the last 30, 40 years. Yeah, 40 years. Shit. 40 years. Okay. And so it's translating, so making models and translating the physics of ice sheets into mathematics and try to predict what ice sheets have done in the past, but also what they could do in the future. So how does an ice sheet work? That's in the first place you need to understand this. So ice sheets, they gain mass through snowfall, and they lose mass through melting or through the calving of icebergs. And so Greenland, for instance, it's 50-50. I mean, yeah, the Antarctica as well. So no, Greenland, it's dominantly the loss through melting. So there's an equilibrium between the amount of snowfall on the ice sheet and the amount that is lost by melting. In Antarctica, it's 50-50 melting and the breaking off of icebergs. So if you read in the press that there is a big iceberg that broke off, it's normal, because it's just compensating for the gain of mass. If you would have too many of those icebergs, then we have a problem, and that is where we have this extra masses. But it's a normal mechanism. Mostly these icebergs that break off, they have the size of a province of Belgium. A small iceberg, it's like typically Flemish or Walloon Brabant. A bigger one, the last biggest one was the province of Luxembourg, which is the biggest province. Yeah, since I'm into this iceberg thing, I know the size of provinces. So yeah, and then modeling, what is that? Well, ice sheet models, they are based on ice physics. And the physics is conservation of mass, energy, momentum. These are the basic equations. And so if you have a physical process, and we take here, for instance, basal sliding, then you translate that sliding, what are the parameters that govern that sliding? So you can have a mathematical description of that. And that mathematical description you make into a model, and it's a model world, meaning in a computer. And then from there on, you can make predictions of how such an ice sheet will react. If, for instance, you get more sliding, or if you get higher temperature or a lower temperature. So that means you need to have descriptions of how this ice deforms. So you need to understand the physics and translate this physics into mathematics. Yeah, this looks rather simple, but in reality, it's solving differential equations, which is a lot of fun. And then these differential equations find their way in a computer code. And so this is a piece of the computer code of the recent model that we are currently using. And that's a model that is used actually for predicting all the predictions that, for instance, the IPCC does for the decades to come. But yeah, you need to validate that. And so we can compare the real world with the model world. And here we see the velocity of the ice sheet. So how fast the ice is flowing. Because the ice flows, transports ice from the center of the ice sheet towards the coast, from where it detaches into icebergs. And so we see this here, the observation to the left, based on satellite data. And then on the right, we have the model world. And okay, the colors are different, but it represents the same thing. We see the same features appearing. Of course, a model is as good as its boundary conditions, and we live in a world that is, a model is always an abstraction of reality. It's a simplification of reality. And even though it is a simplification, we would like to bring in more and more processes that are important. And there are quite a number of processes. An ice sheet is not only deforming ice and transporting ice from the center to the coast, it's influenced by the amount of snowfall, by the amount of evaporation, sublimation. So it's an interaction with the atmosphere, an interaction with the ocean, where the ocean is melting the ice sheet underneath. But then there is also with the bed where the ice is resting above. It's also, you have subglacial water that is produced, and that also defines the slipperiness. And then in the model complexity, there are also tipping points involved. We know from not only from theory, but also from observations and theory built on observations, that ice sheets may lose suddenly a lot of mass, as one of these simulations here in the bottom shows. And this is due to instabilities that may occur. The problem with these tipping points is that we know that they exist, but it's very, very difficult to determine exactly when they will operate. And that leads to a lot of uncertainty. And I show you here a result of a model. It shows, one of these fast-flowing glaciers, Thwaites Glacier, where a lot of things are happening right now. Jurftina is a very big glacier. I mean, for those people that have seen glaciers, for instance, in the Alps, that's a glacier of a width of maybe a couple of 100 meters or a kilometer large. In Greenland, we have that it's 10 or maybe 20 kilometers. In Antarctica, it's 50, 100, 200 kilometers in width. And then the length is several thousands of kilometers. And so here we see an event. You see the time showing how a collapse of that ice sheet is possible. So with the retreat and the acceleration, so the colors show the velocity. So it's done with the model that, so I need to go back. Sorry. Oh, it's wrong. Yeah, it's done with CORI. CORI is the latest model that we have developed at ULB. CORI means ice in Japanese and movement in Maori. Yeah, I just wanted to add this. Yeah. We are dealing with a lot of uncertainty. And so for many, and that is our common ground, because with models, we just do not do one run. We let a model, we have different parameters to consider, a lot of spaces to consider. And so we are dealing with a lot of uncertainty, and we need to live with that uncertainty. Now, uncertainty is a concept that is sometimes very difficult for people to grasp what it exactly means. If you're uncertain, it means, it's not sure, so maybe it's not happening. And that is wrong. Uncertainty, in all this uncertainty, we have a lot of certainty. But it's just that we can weigh this statistically in terms of probabilities. And I know that for many people, statistical courses were the worst in their life. And that's a pity, because we live in a world with a lot of uncertainty. And political uncertainty, economical uncertainty. And it would be good if we could have a good grasp of that. But the thing is that the uncertainty helps us. It's not a barrier for prediction, because it really helps us to show that for high warming, so if we continue and do not mitigate our warming, that we are pretty certain that major collapses will occur in the centuries to come. So we have a very likely retreat. So to finalize, I would like to go to this, as Raoul has mentioned, the sonification. So what I call climate grooves. So data sonification. Data sonification, you have a lot of possibilities in that. Basically, it's an auditory display or an auditory representation of data. And that can be like almost everything. I mean, and else will show some other kinds of sonification. There's plenty of ways of doing it. But the way I do it here specifically is mathematically translate data points, data into sound by mapping this to pitch. So pitch will tell you if you have a high note is like a high temperature, a low note is a low temperature, just to make it simple. And then you can make it into sound. You sonify basically a graph of how temperature changes in time. So you can use that to detect patterns in data that are not really visible. If you hear something, sometimes you may be more perceptive to changes in what you hear. It can be used to raise awareness. It can also be used to deliver messages. I try to make groovy melodies, basically earworms, a short sequence of sound and you repeat it all the time, and then it sticks to your head. And that is typically that is used both in classical music as in modern music. And so you will hear it here. You will hear the CIs, and so you will hear it here. It's played on violin. It's a melody that you see in the bottom, and that melody is based on the anomalies in CI's extent. So it starts high, and then it goes slowly down. And the way it goes down is determined by the data. And this is built off of 16 notes that are always repeated on that same violin. Then on top of it, I put an electric piano. It's something that we performed here a couple of weeks ago, here, with a violin and with some synthesizers. So this is now how you are now listening to how the sea ice between the end of the 1970s until now in the Arctic, the extent is changing. And with this, I leave it.
Thank you very much.
Thank you very much, Frank.
Yeah, you can just move on.
Okay, thanks a lot, Frank. So now our second speaker tonight is a Belgian sound artist, Els Liane. She has an artwork that is here in the exhibition Uncharted, and she will talk about it in her presentation. So she has been working with sound and field recording, especially since 2001, with just 2 small microphones to begin. Els has spent more than 2 decades listening closely to the oral landscapes that surround us, zooming into hidden rhythms, textures, and vibrations that normally remain unnoticed. Her work transforms this captured sound into performances, composition, and installations that transport the listener into imaginary yet deeply organic environment. Through the way she positions and shapes sound within a space, her installations create new perceptual architectures, sometimes emphasizing spatial boundaries, sometimes dissolving them entirely. Els often plays with the tension between what we see and what we hear, exploring how perception shifts when sound becomes the primary guide. Tonight, she will lead us into her approach to listening, space, and the invisible sonic layers embedded within our environments. Thank you, Els. I let you the floor.
Thank you. I don't know. Yeah. So thank you for the introduction. I would like to guide you very fast forward through my practice as a sound artist over the past years. And as you can see on this picture, I've always been very passionate about the sounds surrounding us, about the oral landscape. So you could say that I prefer to look at the world through sound. So maybe it's interesting that we start by listening to the sound that belongs to this landscape. A bit abrupt, sorry. But to start by the beginning, I started my practice by making a lot of field recordings. I would scan the environment with my microphones, and I would really record all kinds of sounds in these landscapes. But I noticed that I tended to really always zoom into certain sonic events. I was really triggered by very tiny, crispy, subtle sounds, very textured sounds. So therefore, my microphones for me were not only a technical necessity. I really saw them as an extension of my body. They were my mobile ears. And these field recordings, I would use them to make compositions and to make performances. And I would feel very much in charge of what kind of sounds that I would tune into, what I would record, how I would record them, how I would use my tools, until I arrived one day at this place. I'm sorry, I can't make fades with this. It's a bit harsh. So people who have been in such an environment will probably have recognized it, but this is a recording of the Amazon forest in Brazil. And actually, at this point, I couldn't decide anything anymore. I couldn't distract or extract. So one tiny sound was impossible. This environment is very dense, very layered, very loud. So the only thing I could do was just place my microphone, remove myself, so the natural habitat would restore itself, and then listen back to the recordings only afterwards. So this experience changed me a lot. It changed a lot my way of listening and recording. But also, for the first time in my practice, I felt like it wouldn't be enough to just play back these recordings through speakers to an audience, make a nice composition out of it, because it would never translate my experience of that place or what I encountered there. Because very often, because also when I was at this place, I had the feeling that my ears became my eyes, like I could hear a lot of sounds, but I couldn't see anything. So also for the first time, I felt like I had to add a visual element to my sound recordings. So this is when I created my very first sound installation. It's called the Mamori Expedition. And actually that sculpture is a visual translation of this drawing. It's a GPS drawing. Don't ask me why, but during the travel, I had a GPS tracker with me. So I think I felt safer knowing that the satellite could know where I was. I don't know. But anyhow, at the end of my travel, I had this GPS drawing, and for me, it's really like a visual diary of my recording trip. So I translated this shape into a 3D wooden sculpture, which I then filled with water, made it dark with brown pigment. And the audience would receive a mobile listening device and a stereo underwater microphone. So actually at that moment, they were able to make their own field recorders travel or to travel through this sonic landscape. And then I want to shortly talk about the work that is shown here in the exhibition. It's Vibrant Matter. And I made this work after having made a trip to Iceland, because I wanted to go to Iceland for a long time to record the breeding season of the birds, because it's nicely quiet there. Well, at least at that time, I don't know now. So I went there and I made a lot of sound recordings. But actually, I was really more struck about the visual landscape in that place. I will show you some pictures so you can get an idea. Actually, whether I was seeing moss or stone or lava beach or glaciers, it seemed like all of these huge landscapes were like stuck in the middle of a metamorphosis. I'll show you a bit more. It's so you can grab the size of the landscape. But actually, what was even more interesting is that while this visual landscape seemed very static to the eye, underneath the surface, there are ongoing processes that can be measured and recorded and articulated through sound. So I thought it was like a very interesting contrast that you had this very vast, still landscape, but underneath there was a lot of activity, as if I could listen to the history of how this landscape was being shaped or still being shaped at that moment. So you had like bubbling mud pools. I did some experiments trying to pick up some vibrations next to the Geysir. And this is a spectrum analysis of a volcanic eruption. For me, it's a nice image of this idea, this contrast between this still visual landscape and this very active sonic activity underground. And this is actually what I try to capture or translate into this work, Vibrant Matter. And actually in this work, it's a big sheet of paper, and through the sound of the moving paper, people understand that they are watching a landscape, let's say abstract landscape, that is constantly transforming. But then the longer I work with sound, the more I started to wonder, like, what is sound? What is this material that I can't see nor touch? Like, who are you? Because it felt like the longer I worked with sound, the more distance it created. Because in working with sound, I always have to use a lot of technical devices, put them in between me and the material. I have to use microphones, computers, loudspeakers. So I thought, like, what can I do to make this distance smaller again? Like, how can I make this material visible or tangible? So how can I grasp it again? So I call it a poetic research into sound as a physical phenomenon. Because until then, I had always looked at sound as an end product. Like, I would grasp the sound and mold it into something else. But what if I would go back to the source, like the moment the sound is shaped, to look at it actually as a physical phenomenon, like a vibration, a wave, or a variation in air pressure? So I had to enter the world of science. And I decided, like, I wanted to go back into that moment of time where they, for the first time, discovered or understand what sound was. So I went back to 19th century, and I used as a starting point the book of John Tyndall, Sound, a Course of 8 Lectures. And in collaboration with the Ghent University Museum, we reenacted several of these historical probes, which was a lot of fun. It was very interesting, this collaboration. And with everything what I had seen there and learned, I went back to my studio and I tried to set up my own experiments using soap bubbles, laser pens, balloons, lightning powder, white powder, all kinds of things. And normally what I do after a long research is that I would create an installation, show this to an audience, but actually where I started with this one question, like, what is sound? It seemed like there were so many more questions triggered. And also entering this world of science, it made me wonder how I work, how they work, and many questions. So I decided, like, making one installation out of this will not translate my experience of this whole research. So I decided to open up this research towards the audience in the form of a lecture performance called Ways of Seeing Sound. So in this lecture performance, I start by demonstrating live several historical probes to the audience. And slowly, this lecture evolves more towards a kind of poetic performance where I trigger more and more experiments and I reflect about what sound is, what it is to me. Here are some impressions. And then afterwards, the work is also can be visited as an installation where several of the probes are activated automatically. And as if you enter a kind of laboratory or my studio, and the longer you stay, the more different layers you can discover about my research. To end by today, 25. So this year, the last work I presented a few months ago is called Figures of Thought. And in this work, I wanted to look at the effect of sound on smoke, because actually it was one of the probes that I had seen in the book of John Tyndall. And I was, of course, very fascinated by this because they are two ephemeral materials. So I was really curious how they would work together. We tried some tests also at the Ghent University Museum. We tried everything, but it didn't work. But I couldn't let go of it. So I went back to my studio, and then I took a thin box and a soldering iron to create some smoke. And I attached a string on top of the box and made it vibrate with sine waves, mono frequencies, because okay, they're clear sounds and I can maybe more easily get some results. And I did have results. And luckily I filmed it because this is the only time it worked. And then it took me another year or longer. But at least I had seen it. So I knew it's possible. So I couldn't, for sure, I couldn't let go of it anymore. So I tried different setups, different tryouts until I came up with this prototype. Because for me, I did first tests with the sine waves, but you know my background in field recordings and my love for these very rich and textured sounds. For me, it was important not to work with what I would call maybe more scientific sounds like sine waves, but really be able to work with more complex sounds, with voice, with music tones. So that all worked out in the end. And the result is a kind of camera obscura object. It's a one-on-one experience for the audience, where they can see live different smoke figures formed through the use of sound. Okay. I will also give you some visual impressions. And together with the smoke made by the sound, you can also, while you experience this work, hear my voice close in your ear. Because for me, as I describe here, these two ephemeral materials, sound and smoke, for me, they reveal profound paradox of presence and absence in a place where nothing holds everything. So I reflect also about absence and presence and everything and nothing. And as of today and the next days, I'm trying to set up a live performance because I want to find out if I can use this box as an instrument to play live with the sound, the smoke and the light, to get myself again into another relation with this work and another relation between me, the audience, and what happens here with the smoke and the sound. Thank you.
Thank you.
Thank you very much, as we are even early, which is wow.
Okay.
Okay. So the idea now is to launch a bit some conversation leads. But first, I want to play the easy way for me, at least. So you both know each other a bit, because by chance, in a way, you already met during the vernissage of the exhibition here, and we also prepared a bit yesterday. But I guess it's a bit the first time that you enter a bit deeper in the world of each other. So I just want to ask if you have, by any chance, a burning question for each other.
Yeah, sure.
Yeah.
But do we
Yeah,
take-
you can use this one. Yeah,
Is that working?
it should.
Well, John Tyndall. He's one of the first glaciologists.
Oh, really?
He was one of the first in the Alps that put rocks on a glacier and then went back a year later to see that they had moved and that they didn't move near the edge of the glacier, but they'd moved in the center. And he was one of the first to describe the flow of ice. John Tyndall. He was also he was one that also was working. He explained why the color of eyes as well. Yeah, he
Wow,
did a lot
I
of
didn't
things.
know.
Yeah, he did a lot of things. So I when seeing this, it's amazing that
Mhm.
this. I love it. I love the. So the and especially on the last thing, I do have a question. So you're using. I mean, your basic is sound, and you put it into. You link it with the smoke, but aren't you then? Because in the end, you end up with visuals. So is it that not a visualization of the sound and suppressing the sound in the end?
I should ask the people that experience the work. In my experience, it isn't, because it's. I believe that if you balance it in the right way, but it's always difficult with installations. You should experience them live to fully capture what's happening. But I believe that if you balance it in the right way, what's happening visually and sonically, that it can become something new, where you can't take away either one, because they have become a new entity or something. So I'm not afraid that it will suppress my sounds or recordings.
No, the thing is because we are always very strongly attached to visuals more than we are to sound, and so sound without visuals is sometimes more difficult than with visuals. With visuals, the sound underlines the image or what you see, and then but if you only have the sound, you have to focus on that sound, and that's a completely different. At least to me, it's a completely different experience.
Yeah,
It's the one that I prefer.
with or without.
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 So I'm surrounded too much with visuals, and my whole life is all about visuals. That's what you do as a scientist. You visualize things, you write things down, you read things. It's nothing is done with sound, and that's a pity.
Mhm.
I wish there was more sound.
Sometimes sound is used as a scientific data, right? Even for glaciologists, no? I read it when preparing the scientific edition of the exhibition.
The thing is, there are some linkages in the work if you're working with like say sine waves that you produce and you do stuff with it. Well, I work a lot. All the measurements that I do, like on ice, is using radar, and radar is just it's a wave that you send through the ice at the different frequencies, and then you get a thing back. Well, this was my first idea of sonification, but it didn't go any further. But the thing is that the frequency of one of the radars that I used, that the frequency of the bounce back of what. So this is the reflection of the signal that you send from the surface to the bed, and then it comes back up. That frequency was in the audible range, and you could hear it, and it was different for different ice thicknesses, at different areas where
How does it sound like?
ugly.
Okay.
Because unlike a sine wave that has no harmonics, this was too many frequencies altogether. So it's very noisy, and so maybe something to filter out. Maybe you should do something with it. I would love it.
We'll talk later.
And you have a question for Frank?
There passed so many things, but when you were at one point talking about the tipping point, and then we cannot predict when it will be there, but quite predictable it will be there at a certain point maybe. And then you talked about the solidification. I was just very curious how that tipping point would sound like. Very deep or very high, or
So it's very difficult to predict the tipping point, and especially because we always think in a time domain. And I think this is the scientific approach that we have is what will temperature be at the end of the century? We look at that. Some people have turned that around and they said, well, what would the temperature? So how many heat waves someone would experience that is born today compared to someone that was born in the 1960s? That's a different way of looking at time and the impact on time. But the thing is with the tipping points is that, and especially for Antarctica, they are geometric tipping points. We know where they will occur. And the thing is that at a certain moment, the glacier needs to retreat. And if it comes to a certain point, from there, you will have a tipping point. That is something that we can relatively precisely predict. But to get to that point, that is more difficult. And how it would sound, yeah, I think you can leave it up to your imagination. Like for instance, if it is in terms of mass, and if you would make a sonification and say, well, this is the rate of the mass loss rate, it would lead to a peak. I mean, you would like go up. If you would scale it, it would like a whole period of almost nothing is happening, and then suddenly, whoop. Yeah.
I saw someone comparing it once, like would put a book on the table and then slide it on a certain point. It was like it's like really.
Yeah, you could
Not
like
like a
take
gradually-
like a razor, an electric razor that makes if you run it and you put it on a table, then it will make small movements and you don't know where it will go, but at a certain moment it will reach the edge of the table and by gravity it will tip over. And that's a very good analogy because you have the movement of the razor, which is unpredictable in which direction it will go, and it's then also unpredictable how much time it will take to fall off the table.
Thank you very much. So I have another question for you. So for you, both of you. So in your work, you are in a way translating or reinterpreting phenomena, natural phenomena, into, you are bringing it from one system of representation to another one, like into sound or into a model. And when you do that, you have to choose in a way what to preserve and what you allow yourself to transform in a way. And in your practices, what is it? Like both really technically or physically, or more at the message and symbolic level? So what do you choose to keep, or what you don't have the choice to preserve, and what you can just make it go?
Well, yeah, in science we follow the scientific method, and that is that you can, of course, do a scale analysis to see what is a process that is like more important compared to another. What is the leading order of change, or what is the leading order element in there? Like for instance, for glaciers, a leading order is the amount of mass they receive by snowfall, which is a leading order over the way they move because they are not moving that fast. And so it's the snowfall. If you know how much snow falls and how much melt you have a pretty good idea on the behavior of the glacier at a lower order. And then you can always add more details. And the thing is, of course, you have some elements of, let's say, emotional elements that come in there, in the sense that people that observe things, they discover new things, and they say, well, we discovered this, that there is water penetrating underneath the ice, and that makes, that leads to a lot of melting, and that will accelerate glacier mass loss. So the first thing they do in the observation is correct. They see that there is more melting. However, the inference that they have afterwards, that's the only thing that you can do, is using models and doing that scale analysis. And that is something that we see now very frequently in scientific literature, that people are measuring something, but then already inferring what would be the impact of their measurement on a global scale. And there you need to be very careful. So there is always an emotional factor that comes in there, or maybe also a factor that people would like to see their things as being important that they have observed. And it could be important, but it takes time to understand to what order this is of importance.
Thank you.
Yeah, I think within my practice, I'm kind of free to use whatever I collect, and then it depends on the project I'm working on, and then somehow it's a very intuitive and organic process, and the end result, somehow what I compare it or level it to, is that it stays faithful or true to my artistic integrity or my artistic specific language. But that also evolves and changes over time, as you have seen the way I listen or record, or how that changes me or my approach. And I think at the moment when I did field recordings, actually very often my field recordings would stay into my archive for a very long time, because when talking about sound and the impact of sound and listening without visuals is, for me, it's something very personal. And it's also something very sensorial. Like when I listen, I always say, like, I listen with my ears, with my eyes, with my touch, with my smell. It's like when I listen, it's not like my other senses are not working. It's actually the opposite. Everything is working so intense at that time. So very often I would leave my recordings in my archive, so that would calm down a bit, like all this intense experience I had, so I could look at it or listen to it again in a different way. But then somehow, if I work with them in compositions, these experiences or memories of that place or recording will always kind of intuitively or unconsciously weave itself throughout the composition. So almost like being guided by the sound, and instead of me trying to fit the sound into something.
Thank you very much. I have a feeling that you even actively try to make those sensory experience mixing together with the last project, where you really show us, you add a property to sound that is invisible by making us see the physicality of sound. There is a phone. I have another. We still have time. So obviously we
I
are.
wanted just to
It's
very interesting that you mentioned all these other sensorial because as science, as I said, we are mostly into this visual, and then you can also listen to data, which is also a bit obvious. But okay, smelling data is but it's a pity that we are so probably evolved in such a way that we have our complete focus on only visuals. That is really dominant, and that these other sensors are not used or underused maybe, and that would be maybe fantastic.
But do you think it could be valuable?
Yeah, I'm sure it is, but I have no answer on how to do it. but I'm sure it is. It should be possible.
Yeah, next time we will take with us a biologist or someone like that. So we are talking about the unexplored, uncharted. So as you yeah, we both talked about that in your presentation about uncertainties, doubts, etc. And my question was to know how you navigate these uncertainties in your practice. Is it sometimes frustrating, sometimes in the opposite way motivating? Is it productive? And a second question is about the scale of the natural systems and the landscapes that you are studying in a way. So it's about something that is bigger than us, huge in terms of scales. And does this topic of study in your work require a specific kind of humility? Yeah, this is my question. So talking about
two
scale
questions.
and uncertainty.
Two vast questions.
Yeah.
Go ahead.
Just stay within in the thematic.
I have another
If
question
I'm
about your mathematics. I think there were a mistake in the equation.
Oh yeah, sure.
if I remember well, like the first part, if we get kind of frustrated or are encountered with certain limitations, right? Yeah.
Yeah, it's about uncertainty in your practice. How
Yeah.
do you manage that, and about the
If-
scale of what
yeah.
you are.
If I'm very optimistic, I would say that the limitations, or maybe sometimes my naivety with which I start a project, are probably in the end my strongest creative tools within my practice. And yes, there's a lot of frustration, but there's always somehow also a belief, or naivety that some things must be possible or are possible. And yeah, I really believe that working with your limitations bring you to a next level, because like recently I was talking to a scientist within the Department of Physics. And I was talking a bit about my work and for a new project, and I referred to him to my latest project with the smoke and making the sound frequencies possible. And he didn't stop saying like, but it's not possible. It's not possible that you could see this with the eye because and comparing it to a difficult formula. And so he lost me in that conversation. And but I did it. I have the proof it works. So it also depends what you're looking for, of course. But yeah, that would be my answer for the first part of the question. And then I forgot the second one already.
The one was about the large scale of what you are studying, or at least interested in. Does it require a kind of humility inherently to your practice?
I would say, because my practice is not always in big or huge landscapes, but I would compare it then to sound is also like a huge terrain of possibilities. And for me, it's just very important to stay in wonder, even stay in wonder with this material or matter that I work with since 15 or 20 years, but to still stay curious about what it can learn me or what I can do with it. So if I refer back to the lecture performance I made, Ways of Seeing Sound, where I was asking like, what is sound? I think in my practice, it's not so much about what is sound, but what is sound to me. And I think this will always bring me to new experiments and to new findings. So yes, I never think I will be bored by. So in that way, stay humble towards the material I work with.
Thank you very much. Frank, you have
I
something
will
to say?
start with the second one first.
Yeah,
Second
yeah,
part, because
you
this
choose.
is- well, I think the image was clear. The first time I went to Antarctica, what I remember is that I was standing there. I was dropped by a helicopter in the middle of nowhere in just this white space, and I was just dazzled and completely lost, and like everywhere white. And also, I mean, I spent 3 weeks on a ship, and you have these engines all the time, and then suddenly these helicopters go away, and then suddenly you have that silence. You hear the wind, So you get into a new reality in which you're almost in an emptiness, in a space of emptiness. And then until this stopped, until someone gave me a shovel, and I said shovel, because that is what we do most of the time in Antarctica, shoveling, because you get snowed in all the time. So that is, but that was a very humiliating experience. I mean, compared to the vastness, I've been driving with ski-doos to do measurements over an area that was as big as Belgium, and it's still a dot on the map. So it's you think you're doing a lot, but it's not. It's there's also something, and then on terms of uncertainty, uncertainty is completely part of what we are doing. You would say it's exact science and that everything would be exact. It's just that there are a lot of physical parameters that we don't know or not know exactly at all. We know the speed of light. We know gravitational acceleration. These are like the constants around us. But there is also a lot that we don't know. And so that leads then to uncertainty, and finding your way, digging your way into uncertainty is also important. And then I said about the different processes, what is an important process and what not. I'm jealous on artists that they have much more freedom than I have to make mistakes. And basically, I would love to evolve through mistakes, making mistakes all the time, and then say, "Wow, this was a lovely mistake." I sometimes do it. I like to. I'm just fond of symmetry, and so I make ice sheets that are completely symmetric, and then I like to break that symmetry by any or other process, and it becomes a fractal landscape that you build with this. And this is all based because these are equations. You can do a lot with these equations. Of course, then the ice sheet is not the Antarctic or Greenland ice sheet anymore. It's my model ice sheet, and it's like my personal ice sheet. So it's my little dome, mathematically described, but it's the same equation, it's the same model. But I like to do those experiments and try to find mistakes in it, or create mistakes and get lost. I mean, one of the papers that I cite the most is of a colleague that proved that I was wrong, and that is it is a way that showed that we made an improvement we moved on in science. And so you learn from mistakes, you learn from things, and that is important. And that is also a part of being humble. And I think many scientists lose the part of being humble, or not humble enough anymore. It's like, we are right. You have in certain domains a lot of discussions. I'm right, you're wrong, and so I have seen a lot of violence in certain areas, and I don't like it. So I like to learn from mistakes and make mistakes. And it's important to make mistakes.
Yeah, if I can add something to that, I had it often when I was doing field recordings, and I always shared it with people who wanted to learn about field recordings, that I stopped going to a place with a certain expectation, like I want to record this and I'm going to do it like this and that. Like, just go to a place, take my time, sit there for a long time, and then things would appear for themselves. Or very often, when I would make a recording with a certain idea, and it would turn out completely different afterwards, this seemed to be the most interesting recordings to work with. So yeah, I agree.
Okay, thank you very much. So we had another question to have together, but I also need to let the time to the audience to ask their questions. So I just put the quote here. That is from a paper about art science, how artists and scientists explore the world together. Maybe it will spark a question in the audience. So do you have a question linked to that or to the equations?
I have several questions. Hello, thanks a lot. Yeah, I have several questions, but I'll ask one by one. First, I'm really curious, why is snow white?
That's a very good question. So colors, yeah, and I'm colorblind, so yeah. But colors, we go back to John Tyndall. What makes colors is how it interacts with the energy. Like, why is the sky blue? It's because you have Rayleigh dispersion, and so because you have very thin particles in the higher atmosphere, and so they filter out the blue light of the visible. And so if you have all the light, if you reflect all the light, then you get white. So that is the way. It depends on how colors of items are defined by how they interact with the light energy we get from the sun. And so it depends on their composition and plenty of things. Yeah.
Can I ask another question? I
Yeah,
have
yeah.
two more, but I don't know if somebody else.
Maybe we can
Exactly.
come back. Yeah.
Hello, thank you. I have a question for you, Els, concerning. Well, I want to come back to this visualization of sound, which I like very much with the idea of this smoke. So I don't agree so much with Frank about the similarity of it, in the sense that for me it's something completely different. With your sound, you make something linear in time. While if it's a picture, so you freeze, in fact, the evolution of your melody, let's call it, in one picture. So I'm curious if you also filmed it, because then you see, in fact, how the different sounds evolve, and it is like a reverb, so how it stays in time and how it evolves further. So it's a frozen time. But then, of course, you can with the video you can even see the accumulation, and then you can say when to say staying in climate change also. So the accumulation of smoke, you see how things accumulate, but you see, in fact, the whole time period at once.
Yeah, so the question I heard is if I filmed, but I filmed it. Yeah, it's film fragmentation, and for what I'm trying now to work with it in a live performance, it is also what is happening live is filmed and then projected or amplified for an audience. But I'm not sure if you have had like a more specific question regarding it towards me or not.
No, that was just a
thought,
thing, and curious. So I would love to see it also evolving as a video. That's all.
No. I people may disagree with me. I'm very happy with that. I don't think it was a disagreement. But
Someone else has a question? Because Laura has a lot. So. Yeah.
Thank you both for the wonderful talks. It's maybe a bit of an impossible question, but you both go to places and you're there either to record data or to record sound or to sit and listen. Could you tell me how, or say something about how the physicality of being in such a place and actually going there and experiencing it enters into either the artwork or into a mathematical model?
Mm-hmm.
What does it do to you within your field?
I think I touched upon that already a bit when I talked about when I'm out there recording or in a place that I don't only listen with my ears but with all my senses. And so yeah, very often these experiences
are translated into my work or are woven into that artwork. So I think it's very much the case when I was still doing a lot of field recordings that it really affected me in a way, and somehow it would also get translated, this physical experience, into the artwork in the end.
Yeah, I think in the first place we are human beings, and then Els is an artist and I'm more the scientist. But as human being, both we react on an environment that we visit, and probably we react in a similar way as being overwhelmed by, especially if you go to polar areas. I mean, you've been to Iceland. It's amazing. I mean, to see, to hear, to feel, to smell, everything. And it has an impact, whether you are a scientist or an artist. It's an impact. Of course, Els will look at it specifically towards art, and I, of course, I have to do my bloody measurements. Yeah, it depends on the weather, and then you have equipment, and you have to test it, and okay, so you're taken up by your work. But yeah, in the first place, it's magical, and I think it's for every place where you go to, every remote place that you go to, that you have an impression that is very intense.
Yeah, for me it's that strong that if I go through my archive, which is filled with quite some recordings, and I see the title of the file, I can remember exactly how I felt that day, how the weather was like, and so it always leaves very strong impressions. And when I came back from the Amazon forest, I wasn't able to listen to the recordings for a very long time, because I think with sound, for me, even more than with images, it would transport me back almost in a physical way to that place, and it just hurt me so much not being there anymore. So it can be very intense in many ways.
Laura.
I'll go fast for but it's just a bit, I think, in the continuation of the question. It's always also this kind of strange aspect when we're thinking of these places that are melting, or the Amazonian forest dying, and that we have all these scientific looking at very specific things, like very specific data, all individually, and it creates this kind of object that is, I don't know, the ice, the forest. And I think also artists extract also in ways a bit differently, but we're extracting and trying to remake these objects. I'm just thinking also, like, if we could imagine in the future, if we don't have these physical, like we cannot go to these places as you are going, or if we have never been there, what kind of like, what could we make sense of all these data? Could we recreate an object that could be close, like scientifically, to what it is, or are we just in a mathematical world? I don't know. It's just trying to think of this, or as artists also, when we extract the sound, if we're not there, how can, there's so many interactions and so many things happening, a bit like what are the archives, I guess, of these spaces, in a way, in scientific or artistic way.
I just immediately have to think, it doesn't maybe completely answer the question, but I immediately had to think of, I had the opportunity to show my work, the Mamori expedition in Sao Paulo, and I was so happy about it, because many Brazilians have never been in the Amazon forest. So for me, it was really special to show it in this city, and I heard from people that they were really touched. It was really a special experience for them to experience the forest through the sound and the movement they made next to the sculpture. And I had the same story from a blind person who had never, he was explained what the concept of a river is and how it looks like, and
but she came to me, she fell to the sculpture and walked around it, and she was like, had tears in her eyes, and she was like, thank you, for the first time I really understand what a river is, because she kind of felt the curves and but a bit aside your yeah, I think there are just many different ways of perceiving reality and many different fragments. So if we would like to make a model of something with everything we have, yeah, we would need a lot of different angles and dimensions and fragments of that one part of reality or idea of reality. Not sure how to or
Yeah, there are several layers in that question, and maybe probably my answer has nothing to do with it. But yeah, from a scientific viewpoint, I mean, we go to places where many people are not able to go. We are lucky for that, for doing that. It also has an importance, but of course, in terms, if you say in terms of climate and environmental change, many of these systems and ecosystems, they are degrading or even disappearing. We have something like ice memory. The fact is that many glaciers are disappearing, and there's now an international project that's mostly funded by private funds to go drilling in all the glaciers while there are still glaciers, to get samples out there, but not immediately analyzing them, just storing them, shipping them to Antarctica, putting them there into the center of the Antarctic ice sheet to store them at temperatures of minus 50 degrees and keep them there for later generations, knowing that that center of the Antarctic ice sheet will be fine, even with whatever you can project, but these glaciers, they will be gone. And so it's a climate archive. It's an environmental archive, but it's a way of preserving it. And so it's a way as Els does with sound. You preserve it. It's an archive of sound, and it's also something that gives a legacy for later generations if ever these soundscapes would disappear. And so, yeah, it's a landscape, a soundscape, whatever. I mean, there's a way to preserve it for later generations. And so this was definitely not an answer to your question.
Maybe Laura for the last one?
Yeah, well.
Or you can ask two.
Just one for each. So first for Els, I was curious if you ever go back to the places that you've already recorded as an exercise of understanding how the landscape has changed through time. And then for Frank, regarding also research methodologies, I was wondering if the scientists that go to researching Antarctica, if you ever are in contact with the indigenous populations like the Samis or the Inuits to involve them and to get feedback and from their own knowledge of inhabiting the landscape, the ecosystem. So my questions.
Okay, well, I will immediately respond to your question. In Antarctica, there are no indigenous people. There's no one living there except scientists that winter over. But of course, in the Arctic, you have. And it is true that we are collaborating more and more with indigenous people, and also exchanging and using their knowledge, and including that also in the science. So it's typically in science projects in the Arctic. There is a close collaboration with indigenous people, and also indigenous scientists. So that is done quite a lot, and it's a very important.
I think as for me, since I not really trying to research something with making my sound recordings on certain locations, like, okay, the ones I illustrated here were the more exotic ones, so to say. So I never went back to specific places in Iceland, or I don't have the opportunity either to go back to the Amazon forest. But I always found it very interesting to just go and record in the places I knew very well, because I believe that your ears and body have a certain memory, or they recognize places. So I always would find it very interesting to walk around and listen in the places I'm very familiar with,
and trying to discover new sounds or new experiences of that place by listening to it. Yeah, I wanted to say something else also. It escaped me. Yeah.
Okay, well, thank you very much to both of you. It was very interesting for the rich conversation. Thanks for being there to all of you, despite the strike. And to Melanie and Isel for welcoming us for the, I don't know how many times since the beginning of the exhibition. So the exhibition is still open until the 6th of December, so you still have some time. And thanks also to Laser Talk and Alexandra for the nice collaboration. Right now, so everything is live streamed, and we will have a recording on YouTube next week, I think. If you want to see us once again. So thanks everyone, and let's have a drink together. Thank you very much.
Thank you.